Now we continue with 5.2, liquid. These are the learning outcomes of liquid. First, we look at properties of liquids. Before we continue, liquid and solid are purely theoretical explanation. So I try to summarize the points. So I request students to read as well your notes, your extra notes or your reference book to understand better about liquid and solid, because it's 100% theoretical. Questions will be asked based on explanation. Okay, the first property of liquid and solid, volume and shape. Liquid has a definitive volume but not a definitive shape. The particles are arranged closely but not rigidly, held together by a strong intermolecular forces but not strong enough to hold the particles firmly in place like solid. Particles are able to move freely compared to solid. Thus, a liquid flows to fit the shape of its container and is confined to a certain volume. Second property, surface tension. Molecules within a liquid are pulled in all directions by intermolecular forces. Molecules at the surface are only pulled downward and sideways. Therefore, a liquid surface tends to have the smallest possible area. Liquid surface tighten like an elastic film. Surface tension is energy required to increase the surface area of liquid by a unit amount. This example is for surface tension of water. Now, this is very important. The stronger the forces between the particles in a liquid, the greater the surface tension. Because the surface tension, we look at the diagram. If you look at the diagram within a liquid, as molecules at the surface, you can see the direction only sideways and downwards. While molecule within the liquid, they are pulled in all directions. So you try to imagine the molecules at the surface. If the intermolecular forces is very strong, then the surface will be tightened more stronger. Therefore, the surface tension is very high. Now, the third property, viscosity, resistance of a liquid to flow. The higher viscosity, the more slowly the liquid flows. To make it a simple analogy, is comparison between engine oil and water. So we can see oil has, oil is more viscous than water, because you can see the oil flows slowly compared to water. Factors affecting the viscosity. First is strength of intermolecular forces. The stronger the intermolecular forces, the higher the viscosity. Second is the size of the molecules. The larger molecules or higher molar mass molecules, more viscous because it has strong intermolecular forces. The third factor, temperature. Increase in temperature decrease the viscosity of a liquid. That means the higher the temperature, the lower the viscosity, or the liquid become less viscous. Because at higher temperature, molecules have a higher kinetic energy, they move faster, they overcome the intermolecular forces easily, then the resistance to flow decreases and viscosity decreases as well. Number four, fourth property is compressibility. In liquid, the particles are packed closely together. Thus, this is a very little empty space between the molecules. Liquids are more difficult to compress than gas, because gas and liquid, the empty spaces or the gap between the particles in gas much bigger. So it is easier to compress compared to liquid. The fifth property is diffusion. Diffusion is the movement of liquid from one fluid through another. Diffusion can occur in liquid because molecules are not tightly packed and can move randomly around one another. This is also applicable to solid, but diffusion in liquid is much faster because it's not tightly packed. However, in comparison with solid, diffusion in solid is much slower than diffusion in liquid. For the same reason, the particles or the molecules in solid are tightly packed. Therefore, the rate of diffusion in solid is much lesser compared to liquid. Now we go to vaporization process. Vaporization is a process of changing the state from liquid to vapor. Molecules in liquid moves freely, collide with each other and possess different magnitudes of kinetic energy. Some molecules have a relatively high kinetic energies. Molecules at the surface possess sufficient enough kinetic energy to overcome the intermolecular attractive forces that bind them. Bind them means that bond them. Okay. When the kinetic energy is sufficient enough to overcome the intermolecular forces acting on them, molecules will escape as vapor. So the point here is, can the kinetic energy enough to overcome the attractive forces, especially molecules at the surface? If the kinetic energy is sufficient enough to overcome the intermolecular forces, molecules at surface would escape as vapor molecules. Then vaporization process occurs at that point. Now, factors affecting the rate of vaporization: surface area. The larger the surface area, then the higher chances for the molecules to escape. If surface area increases, rate of vaporization increases as well. Second factor is temperature. As the temperature increases, kinetic energy of the molecules will increase, or more molecules will have higher kinetic energy. When more molecules have higher kinetic energy, then the chances to escape also increase. When the chances to escape increases, therefore the rate of vaporization or evaporation increases as well. Now the intermolecular attractive forces is the third factor. The weaker the intermolecular attractive forces, the faster the rate of evaporation. Because once the kinetic energy can overcome the intermolecular forces, then the rate of evaporation will be very high. In fact, when the intermolecular forces become so weak, then molecules can easily escape from the surface, then the evaporation rate is very, very high.